we have people. Yeah, it's interesting that. Yeah, it's really 25% for each category. Yeah, it's funny. Yeah, thanks a lot. Yeah, so in this case, it's also interesting from the new ones who are only jumping into the OT, and these topics are very critical and very important also for OT engineers or who wants to learn the security, or for security experts who are jumping into the OT. Because with, for example, with help with Labshock, you can learn all these directions from pumps and tags and Modbus to the things, for example, like pentest. And inside pentest, we have for now two modules. We are now will check how we can manipulate this Modbus, not from the operator and legitimate way, but from the different station. Yes, and before this, I'm not today going deeper on the some pen tests or scanning or whatever, only some few steps that are necessary to understand. Yes, the first thing is that we are scanning the network for devices. You can do it with some, let's say, simple and fast scans, as ping scans or SIEM scans. You need to understand which devices you have in your network. Yeah, and after that, you can see that 2.10 is up and something running there. After that, we are going into the, let's say, and scanning some ports to find out what's running inside this IP address. Yeah, of course. Now I am showing some simple steps, but it's require a lot of time to build this data and to understand that 502 is open inside this device. But in our case, I showed you that in this way you can find the Modbus devices. Or another technique, for example, you can scan the network for exactly port if you're focusing on the Modbus. Yeah, if you have access into your switch or into your environment, you are connecting, and the first thing you are scanning your network with for devices. Of course, you are scanning in passive mode or whatever techniques is silent and maybe safe. But in our case, we can say that, yeah, something is running inside 2.10. And let's go into this second tab that we are going to check exactly the tags and inputs and outputs which are running inside the PLC. So the first thing is coils. So we are checking the binary data, boot data that are storing on the PLC for first, let's say, 10 addresses. And we can see that all addresses are full except first one. So first one is on the truth, and maybe something is running there. And of course, we can go and change this. Let's check one more time. This pump is running, so and maybe this address is exactly for this pump. We are sending right coil. Let's see one more time. write coil, so write successfully to address 0. We are checking here, and pump is switched off. And this is the root cause of the Modbus. So exactly the same way was done a lot of attacks, not very famous or altogether. But this is how Modbus is working. So you are sending the coil, and pump is accepting this coil. And of course, if we are going into the network, you can see that some additional IP address 3.30 is connecting into our 2.10. Not only SCADA and HMI is now connecting to the PLC, something else is connecting to our PLC. And if we are going into the traffic, we can check 3. Yes, let's stop it, and we can see that 3.30, not our SCADA is sending the query to our PLC, but something else is sending 00 to our PLC. And of course, the same way HMI or sorry, the PLC, Open PLC cannot understand and cannot check this source that is sending the data, and of course, it respond with okay, I'm changing this address to 0. So for PLC, there is no difference between is it SCADA or is it something else. Yeah, and the same we can do. Let's start pump back so we can send the one. Let's say one more time. We are putting it back, and exactly with the same way we can change the speed of the pump. We can go into the register commands, recheck the starting address and number of addresses running. Here we have 80. Yeah, of course, you need to spend a lot of time to understand this, and this is why it's critical to have your SCADA layouts or all the diagrams in safe way that these tags and addresses are not exposed into somewhere. And after that, of course, we can try to change the speed from 20 to, let's say, 55. And now speed is 55. Because the tag is open for writings, we can see that we can change this tag. And of course, I switch it. And of course, yes, register. We can check that register Modbus 37. If you are make it from the binary into the integer, you will see that this is 55. For reference number, this is the address. And one more time, of course, the PLC doesn't understand that is it legitimate or not legitimate way. He is responding that, yeah, of course, I can change this data to your value. For network, it is the same. So we have 330 is communicating for 2.10. Yes, and in this way, you can run different writings to the coils or register to understand how these communications are working. Or you can also test your own maybe scripts or maybe some commands for clients, for Modbus or whatever. But what, let's say, today this is something new. What I want to tell how to detect this, let's say, not normal behavior that someone from somewhere are trying to change your PLCs. And in this case, on IDS, it will be on the next release. We have these messages. And what to do is, let's say, new Modbus. We can see that new Modbus protocol detected. This is the first and one, maybe simple, maybe powerful, and maybe noisy, but this is only one way how you can monitor the traffic, that to detect all unknown and all uncommon communications that is going into this your PLC. So to monitor the network and to detect these lines that are going into your PLC. So you let's say remember that this communication is okay for you, and you need to detect this one that is new for your networks. And in this case, if you don't have anything else, you need to detect the new communications that is going into your network. For example, new connections from 3.30 to 2.10. So this abnormal communication is going into your PLC. You need to detect them. This is, let's say, the first step to understand how to protect and to how to detect these communications that is not, let's say, documented or not normal for your networks. And after that, the one more things. Maybe let's make it 1 second. And after that, when you have this, maybe you have the ideas running inside your networks and analyzing the traffic. And of course, after that, you need to remove all the false positives. It's, let's say, another story, but you need to collect this data. And this data must go into your, let's say, SIEM or collector or something that you understand that new Modbus connections are going from this 3.30 to 2.10. So these are new communications that are creating in your critical networks segments are logging, and you can extract this data. That something from function code 1, something reading coils from Modbus TCP at this time. This is the first step how to monitor the network. And after that, of course, you need to protect first. Maybe we are switching a little bit how to protect from this Modbus. The first thing is you need to segment your network and, of course, protect your switches to unauthorized access of different devices that are creating inside your process level 2, level 1, or level 3 networks. To not to give this possibility to communicate with PLCs, because if you have this access from let's say this machine into your network, you can change everything what is not protected. And after that, monitor the network and detect these messages that are going from the at this example are going from the Modbus. Or new connections. You can see that we have also this ICMP protocol that 3.30 somehow send the ICMP packet. And of course, this is the first sign that something is pinging your PLC. Why and what the reason behind that. Yeah, so this is, let's say, our Labshock steps to introduce this monitoring inside our networks. This is new and will be released in next week. Yeah, that's all what I wanted to show you about the Modbus, how to protect it and how to make more safer your networks, because you need to understand that if your PLC running the Modbus, it's unprotected, and anything can change your data. Yeah, that's all from maybe my side, and maybe we can run the Fed poll and switch into the questions that we have. Yeah, so maybe the information, what you want to do with Labshock, and to learning or to building or to testing. Yeah, thanks a lot. The idea here is to not only to learn. Yeah, of course, you need to understand the Modbus and communication, but the second question is to test your protection, your monitoring, your logging, how you are protecting your networks. And in this case, we will build this pipeline from the network traffic inside your SIEM. Yeah, so here for learning and for building OT security lab, yeah, more or less, not sure yet. Yeah, so thanks for that. And yeah, of course, questions. Let's go into the questions sections. First one, I will try to answer for maybe simple ones, and after that, write the answers in. Okay. Are these tools freely available? Yeah, Labshock is free available. You can go into the GitHub and install it in your environment. And the Labshock, the concept is that for personal use, it's free and have some time limitations, but it's not so critical. So yeah, you can use it for commercial use or for some more complex or for trainings. You need a license for that. Can we create a new lab and connect them to all other components provided? Yeah, the concept is that Labshock is modular thing that you can connect your own containers, for example, your virtual PLC or your physical PLC. So people are running OpenPLC on the Raspberry Pi and connecting into the Labshock. Yes, it's possible. Okay. So this lab setup has any license and applications? Yeah, some services are under the license that you need to use it if you are using it, of course, on the commercial or companies or for trainings. What layered security approaches are recommended to secure Modbus? Segment your network and let's say switch off, turn off, or make your switch ports unavailable for any connections. How do we prioritize patching or controls for patching? you know, it's hard for patching, and I think it's not a topic for today. For patching PLC, it will not help you with Open Modbus. How can we differentiate between legitimate, anomalous traffic and malicious? Yeah, today I showed you the first step, how you can detect these new connections that are, or new protocols that are running inside your network. Yeah, this is models that understand your traffic. And of course, you need some machine learning or something else to extract abnormal and normal behavior. This is maybe hard, but nowadays we have a lot of opportunities and a lot of tools to do it. What are common Modbus misconfigurations that increase the risk? Modbus misconfigurations that you have open writing tags inside your PLC. So if you have possibility to write the command, it can be misused and let's say abused to someone else. So if it's not necessary to have writings, outputs, you need to make it only read mode. What are the best practices for segmenting networks to protect Modbus? Make layered segments, VLANs or whatever, but at least segment your level 2, level 3, or if you have these segmentations, I think you understand how to do next segments. I mean, how to operator connect from CCR to the other level. This is instrumentation engineering forms, the basics of OT. Don't understand. Can we use Labshock to test our existing Modbus communications, like we having Siemens PLC connected to plant DCS? You can create a lab and connect your Siemens PLC, and after that check the traffic, what is running there, and of course analyze what you can do. This is the concept of the lab. You are recreating your lab and checking what you can do or what you are doing with your environment to protect it. For example, I'm sending the Modbus command from unknown IP address. Are your tools are detecting these commands or not? If yes, is it somehow or someone responsible for doing something? So this is, let's say, the starting point of a lot of questions that are rising after that in, let's say, SOC level or some management level, but this is the first thing that you need to test and at least teach your people to detect these, to detect and to work with these environments. Which one is more difficult to switch from OT to IT or IT to OT? For it's, let's say, philosophical question, but I think both ways are difficult. For the main problem for switching from IT into the OT, if you're, for example, security engineer and jumping into the OT, that you don't have tools available or hardware available to, for example, to recreate testing environment the same as Labshock. This is why I created it to show the users, the people and students that this is OT, because otherwise you need to go into the some factories and see this Siemens, this Modbus and etc. This is the difficult to switching into the OT. difference between tidal collector and network swiftness IDS. The difference is that you have the IDS that is analyzing the network. This is the network swiftness to collect the traffic to find these messages as events to extract the data from your traffic. This is the main point of IDS and network swiftness. And after that, you need to transfer this data into your SIEM, into your central collectors. And this is what is tidal collector. It's not, let's say, fully visible now, but its job is to connect your sources from your network and send this data in your centralized environment. If we have a firewall between the level 3 and level 2 with good rules, there I believe this to receive commands from the new IP. If you have the firewalls, the question is, are your firewalls working as expected and you don't have any rules? Because it's very hard to maintain and handle the firewalls on the critical, let's say, areas. And yeah, misconfiguration on the firewalls. This is one big question. Okay. Can we use Labshock to test our existing Modbus communications like we having, yeah, okay, the same Siemens PLC? Yeah, of course, you can test the communications, your own environments, and this was the main concept of the Labshock. Maybe one more time to describe that Labshock is modular and you can connect your own devices, and it also can work with hardware as IP based, as a network based devices. So you can connect and recreate. Yeah, it's a little bit harder, but you can recreate it and connect. For virtualized containers, you can easily connect it to the Labshock, for example, Zeek, and there is information about how to do it. You can connect Zeek and test your Zeek rules, or learn this Zeek, or you after that in next releases we will connect this tidal collector onto the SIEM, and you can connect your own SIEMs to test this data. Or, of course, connect your virtual PLCs into the Labshock and test it. As for example, Siemens has 1050 PLC, which is virtualized, so you can run it inside the environment and test these connections. I would like to thank you for this webinar. May I know your next webinar and topic? Yeah, thanks a lot for you for joining, and for next webinars, we will think how to handle, and when we will have some information, I think you will know about it. Don't worry. Yeah, you can put some likes if you need some more more webinars like this for, let's say, another protocols, S7 for example, or whatever. Yeah, of course. And today I show you that these new features as a messages, as a real ideas, what I think you have a lot in your environment, and the question what to do with them. Yeah, we will discuss it later.